Question 7. Acyl chlorides have a C double bond OCl. They're very, very reactive. They have violent reactions. They produce hydrogen chloride gas when they react with water, and it produces white steamy fumes. So this one is propanoyl chloride, COCl, with 3 carbons. So this would react with anything with water and would produce hydrogen chloride gas, white steamy fumes. A very violent reaction, so you've got to take extra care when you're using acyl chlorides. They react with benzene in the presence of AlCl3 in electrophilic substitution reaction. Give an equation. Well, let's have a look at the whole mechanism and I'll explain what's happening here. So the electrons in the ring need to attack this is an electrophile, so it needs to attack something that's positive charge. So you have a look at what you're putting onto the ring. So this CH3COCl is going to go onto the ring. So this part, the CH3CH2CO, is going to join onto the ring, and I need to make this positive. So what actually I do is I take the CH3CH2COCl and I react it with aluminium chloride. And aluminium chloride forms AlCl4-. It removes the Cl from here and it leaves a plus charge on the carbon. So where the carbons had 4 bonds, it's had a Cl joined to it. It's now only got 3 bonds and the Cl has gone. And the Cl minus, so the Cl and the electrons in the bond have gone on to the AlCl3. It's made AlCl4-, and it's left this carbon now without enough bonds, without enough electrons, and it's positive. Now that is going to bond to the ring. The electrons in the ring will attack that because these are electrophiles, these electron paired donors, and it will attack this plus charge, and when it bonds it joins on. It doesn't really matter where it joins on in this case because we've got no other groups attached, so we've just joined it on here. The ring has given away electrons, so that gets the plus charge. The C plus has had electrons put onto it, so that plus has gone, and it joins onto the corner. There's also an H on each of these corners that's not shown, so now I've decided to show it, and now the plus charge is in the ring, as I've said, because electrons have moved away from the ring, and we do a horseshoe shape with the gap towards where the group's added on. The electrons go from the bond in the H into the ring, and then that's going to mean that the ring is reformed without the plus charge, and it'll have the full ring circle back in it, and the H will come off as H+. The organic product can be converted into the alcohol shown. Okay, so COCH2CH3 can be converted into an OH. In other words, I've converted a C double bond O into a COH. So instead of a C double bond O here, I've converted it into a COH and added another H. Give the name of this alcohol. So what is it? This part here is propan. So I've got propan, 1, 2, 3 carbons. If that carbon here is carbon number 1, 1, 2, 3, propan, and the OH is at carbon number 1. So at carbon number 1 I've got an OH, an ol, and I've also got this group which is a phenyl. So it's sort of propan with an ol, with an OH at carbon number 1, and a phenyl at carbon number 1. 1 phenyl, propan, 1 ol. What reagent can do that? Can turn a carbon double bond oxygen into an H and an OH. So you could either add hydrogen and nickel, that's one way of doing it. You do that in industry. It doesn't specify that you can't do it in industry, so hydrogen and nickel adds hydrogens. Adding hydrogens to something is using hydrogen and nickel, or you could use something called sodium borohydride. The name of the mechanism, so a hydride ion is a H-, and it would attack the C of the C double bond O, and the C double bond O would break and take electrons onto the O, and then an H plus would come along, because this is usually a methanol or dilute acid, and would make OH. Or hydrogen nickel adding hydrogen is called hydrogenation, so you could have that instead. The alcohol shown in 7.2 reacts with ethanol chloride to form an ester. So this one that I've got in this one here, this alcohol, can react with ethanol chloride to form an ester. That's because an OH group can react with a carboxylic acid group or an acyl chloride group, a COCl, and release a small molecule like water or hydrogen chloride and make an ester, a C double bond O, an ester link. So describe what would you observe when the alcohol reacts with ethanol chloride. Well, ethanol chloride, I've already said, makes white steamy fumes of hydrogen chloride. Name of the mechanism, addition elimination. So the structure of the ester would look like CO. It would have this benzene ring connected to a CH. Off it would be a CH2, CH3, and this O, then this C would be an O, and then C double bond O CH for the ethanoyl chloride. The CH3COCl would be here, and that is an addition elimination. They add on and then eliminate the molecule, such as hydrogen chloride.